In this video, we're going to be doing some parametric first derivatives. In this first example, find the slope of the tangent line to the parametric curve. So that phrase implies we're going to take the derivative dy dx and then plug in some values. Well, remember, for parametric equations, dy dx is really dy dt over dx dt. So we need to do a couple of derivatives here. The derivative of our y, 3 cosine t, would be negative 3 sine t. And the derivative of our x, 2 sine t, would be 2 cosine t. Now they're asking us first to plug in t equals pi 6, so dy dx at t is pi 6 would be negative 3 sine pi 6 over 2 cosine pi 6. Well, our special values are here now, so we have negative 3 times 1/2 over 2 times radical 3 over 2. So negative 3/2 over 2's cross out, root 3. We could do a little simplifying by multiplying by the reciprocal, so we would end up with negative 3 over 2 root 3 for pi 6. If we plug in 7 pi 6, let's create a little room for that, we would have dy dx at t is 7 pi 6 would be negative 3 sine 7 pi 6 over 2 cosine 7 pi 6. Again, special values. Negative 3, this time we're in quadrant 3, so negative 1/2. And then on the bottom we would have 2, and cosine would be negative radical 3 over 2. So double negative making a positive. So again, those 2's would cross out. We end up with 3 over 2 over negative root 3, which would again be negative 3 to root 3. In our next example, find dy dx at t is 1 for the parametric curve. So again, this is a derivative plug-in problem. So dy dx is once again dy dt over dx dt. So derivative of 2t cubed minus 3t would be 6t squared minus 3. On the bottom, derivative of 5t squared would be 10t. We now would like to do dy dx at t is 1. So that would give us 6 minus 3 on the top, 10 on the bottom, so 3/10. In our third example, find all values of t at which the parametric curve A has a horizontal tangent line, B has a vertical tangent line. Well, remember, a horizontal tangent line is going to happen when you get 0 over a non-zero number. A vertical line is going to happen when you have a non-zero number over 0. If we get double zeros, that would be what is known as a singular point. So we need to watch out for our 0 over 0. So let's go ahead and get started with this one. So when we take the derivative of our y, then dy dt is going to be t squared minus 3t minus 4. When we do dx dt, we're going to get t squared minus 4. Now, we're going to want to set both of these equal to 0 and solve. Well, in each one of these cases, they factor, so we get t minus 4, t plus 1. So, could be 4, could be negative 1. Down here, we get t plus 2, t minus 2, difference of squares. So, t is negative 2, and t is positive 2. So we're looking to see if any of these match, and they do not, so we do not have any singular points, so we can not worry about that. So our horizontal tangent line is going to occur at t is 4 and negative 1. Our vertical tangent lines are going to occur at t is plus or minus